Hi, good morning everyone. Let us start with Hadoop introduction. So first, before going to Hadoop, we'll see understanding of distributed file system. What is distributed file system? When a dataset, a file outgrows the storage capacity of a single physical machine disk, it becomes necessary partitions it across a number of separate machine disks. Okay, and file system that manages the storage across the network of machines disks are called as distributed file system. Okay, in Hadoop the large files will be partitioned into small pieces called blocks and stored across a network of machines. Okay, so that is what distributed file system. Let us move to the next slide. So Hadoop components. What are the Hadoop components, main components? So Hadoop, there are two main components in Hadoop. One is HDFS, another one is MapReduce. Okay, so HDFS is like Hadoop distributed file system, and MapReduce, it's a programming model. Okay, so HDFS, it is a distributed file system with faulty tolerance and high throughput for applications. So I can say one more is storage layer, and it is used to storing the data, right? And another one is MapReduce, programming model. It is a programming model with key and value pairs. So I can say it as one more is term is programming layer. Okay, so let me move to the next slide. So this is HDFS, Hadoop architecture, Hadoop 1x architecture. Okay, so before going to Hadoop architecture, let me give you draw a picture and then I'll explain you, right? So what is Hadoop 1x architecture? So for example, this is HDFS, okay, Hadoop. So okay, in terms of Hadoop, Hadoop 1x, okay, we'll discuss what is 1x and all. So Hadoop 1x, there is one primary node, master node, call it as name node, and slave nodes, call it as data nodes. Okay, so Hadoop will follow simple master and slave architecture. So one master, multiple slaves. See, like connecting this way. Okay, so if you can see it here, this is, I can say it as name node or master node. This is right. I can say it as name node or master node, and these are called slave nodes or data node. Data node 1, data node 2, data node 2, data node 3, data node 4. Okay, so let me drag it, data node 4, right? So this is a, I can say it as Hadoop 1x cluster. So Hadoop 1x, these are the storage layer component. Okay, so when coming to the Hadoop, so one more Hadoop, for example, if you consider this is Hadoop, okay, this is complete Hadoop. So we have two components in Hadoop. What is components? One is storage layer and another one is processing layer. Storage layer plus processing layer. So combination of these two, storage layer plus processing layer, is called as Hadoop. Okay, so this comes under storage layer. This name node, data node, data nodes, right? And we have one more node is also available in Hadoop 1x, secondary name node. Secondary name node. This will connect only with active, only with name node. Okay, and also, for example, if you have a client outside, see, there is a client. Client means, for example, you have some data is available. Some data is available. So you want to copy this data into Hadoop. Okay, so when you are copying this data, okay, so let me take it. Some data, you have some data is available. That data, let me take it. Okay, some data is available. This data, if you want to copy into Hadoop, okay, this data will be split into blocks, split into small pieces called blocks, and then storing into data nodes. Each block has been replicated 3 copies. That is Hadoop design, Hadoop architecture design. Okay, let us see how it will be. Okay, so let me take it one more paint. So I'll draw it only for Hadoop. Okay, so here name node, data nodes, five data nodes, right? So it is connecting master slave architecture. It will follow. Right, and one more secondary name node. It will connect here. So I'll write it name as simple name node, and here SNN, secondary name node, and here I'll mark it as, okay, so I'll write it in the end, data node 1, DM means data node 2, data node 3, data node 4, data node 5. Okay, so let me write it here instead of your confusing. NN, name node, SNN, secondary name node, secondary name node, and DN stands for data node. Okay, so these are the abbreviations of short letters. NN stands for name node, SNN secondary name node, DN stands for data node. Now you have a data, you have a client data, some around 200 GB of file is available. Okay, 200 GB file with file name sample dot some text file. Okay, so now if you want to copy this data into Hadoop, okay, you want to copy this data into Hadoop. Generally, normally when you copy a file from your machine to your another machine from hard disk to somewhere, so actual as usual the file will be copied as it is, right? But here it is not the case. Okay, so when you are copying a file from outside to Hadoop, so it has been split into blocks, pieces, like this way, split into pieces. That pieces we will call it as blocks. The big size file will be split into blocks and copied into the data nodes with replication factor 3. It means, for example, if you see, this is, I'm writing some block 1, block 2 something name, okay, some BLK1, BLK stands for block, BLK2, BLK3, block 3, BLK4, BLK5, BLK6. For example, there is a 6 blocks. So for example, just imagine this file has been divided into 6 blocks. Just imagine. So these blocks will be replicated 3 copies. Let us see how it will be. Block 1, so it means block 1 first copy, block 1 second copy, block 1 third copy, right? So let us write it. Let me write the name. BLK1 first copy, BLK1 block 1 second copy, BLK1 block 1 third copy. Like this it will store. Okay, so let me give him some, this one, block 1, block 1. Sorry, so you are not able to see the actual name. Okay, so block 1, fine. Now this is block 1 replicated. Now block 2, block 2 first copy, second copy, third copy, like this. So I'm just mention B2, block 2 first copy, block 2 block 2. Okay, and like this is a block 2. The same way other blocks also will replicate block 3, block 3, block 3, and block 4, block 4, block 4, right? Block 5, block 5, block 5. Okay, let me write it. B3, B3 block 3, B3 block 3, and here block 4, block 4, block 4, and here block 5, block 5, block 5. Like this it will be splitting, like this, splitting the blocks, and each block has been replicated 3 copies into the respective data nodes. So this is actual data. Okay, so actual data will be storing on data nodes in Hadoop environment. So what about name node? So the file permissions, files metadata, the blocks information will be storing on name node. So this is what it is storing on: metadata. Metadata. What is metadata? Metadata consists of file name, name of the file, how many blocks this has been divided, what is the file owner, file permissions, everything. So we have a slide. We'll see one by one. Yeah, you can see what is name node. Name node is the master node, and it stores the file system metadata, and responsible to store the file system metadata in the name node. So what is that metadata? Metadata is consist of information about the ownership of the file, permission of the file, what permissions the file is having, and information about timestamp, what time you copied. For example, if you copy a file now, what is the time now? So based on the time and information about the file size, what is the file size, 100 GB, 200 GB, 300 GB, and replication, what is the replication factor. In Hadoop, by default replication factor is 3. It will maintain. It means when you copy a file, the file will be split into blocks, and each block has been replicated 3 copies by default. By default, 3 copies. So that is a default. If you want the replication factor, you can decrease, or if you want, you can increase. But Hadoop suggested replication factor 3 only. Yeah, Apache Hadoop suggested replication factor is 3 in Hadoop. Okay, so that is based on your client requirement. If you go down, reduce the replication factor, you can reduce, or else if you want to increase, you can increase. That it's up to your client requirement. Fine. And also name of the individual blocks, location of the blocks. So what is the block, each one? So we have, for example, previous case, we have copied some file. It has been, just imagine, 6 blocks it has been divided. Just imagine that 6 block, each and every block is a name, right? Some BLK1 something, a block name. What is the block name? And location of the blocks, which data node it is stored. That is called, what is that? Metadata. That metadata will be storing in name node. Here, name node. And here data nodes, it will store actual block information. Okay, so actual block it will be storing, right? So let us see. That is name node. Okay, so what about next? So data node, storage layer, first component is name node and another component is data node. So data node is a slave node in a Hadoop cluster and responsible to store the actual data in the form of blocks. Each block replica on a data node is represented by 2 files in the local native file system. One is, for example, you can see the first one example here, the HDP user and something date block BLK 10122 some number. The block is like when you copy some data, the file has been split into blocks, right? That is the block information. And another one is this block's metadata, this block metadata, this block name, this block timestamp, everything will also maintain in data nodes locally. This is called data nodes local copy of representing of each block replication of the native file system. Okay, and the first file contains the data, actual data block, it has been divided, right? That actual data. And the second file contains blocks metadata, this block metadata including the checksum for the data and the generation of timestamp. And what is the data, date you have generated the file, block, everything, all the information is storing on the, again, metadata file of this data node. Okay, that is related to the component of HDFS component data node. And another one is, we have one more is secondary name node. We'll see one by one. So HDFS, Hadoop distributed file system. So how it will be started, how it will be implemented. So HDFS is a file system written in Java. So based on Google's file system GFS. So before inventing Hadoop, they have taken some GFS as a reference. GFS stands for Google file system. Google file system, they have taken the reference and then they started with Hadoop file system. Okay, and it sits on top of native file system such as ext3 or ext4. So if you see the diagram here, the blue box indicates Linux machine, Linux server, Linux laptop, I can say simple Linux machine, physical machine. Okay, so each and every machine there is a disk available, right? Disk means what is some internal hard disk inside the hard disk, that hard disk. And that hard disk, what we can store it like, so we need to install some operating system. That is, so Hadoop will run on top of Linux or Unix. So here we can say it as a Linux. Now no more using Unix. Unix is a purely command-based operating system. Now everyone are using Linux versions, Linux flavors, multiple types of Linux flavors available, right? And so in the disk you can install your OS operating system, that is a Linux machine, Linux version. So we have different type of Linux versions: Red Hat CentOS, SUSE Linux, Debian, Ubuntu. Separate Linux flavors are available. Multiple Linux flavors are available with their different versions available in the market. Okay, right. And we can install in here. And also it will native operating file system, that is Linux file system, where it will be storing on top of disk. It will store, so we can install here. So this is called ext3 or ext4, that is a file system. And on top of native file system we are going to install Hadoop, our HDFS or Hadoop. So it means, so Hadoop is going to install on top of Linux, right? Native file system Linux. Okay, and it provides redundant storage of massive amount of data. So by using the Hadoop is designed for to storing massive in the sense meaning huge amount of data. We can loading and processing. We can load it, and for the process it, for that Hadoop is designed, okay, using industry standard hardware. And also at the time of loading, data is distributed across all the nodes. So what is all the nodes? We have data nodes, right? So when you are loading the data from outside to Hadoop cluster, it will be distribute across all the available nodes. For example, if you have installed a cluster called 100 nodes, right? So that will be distributed all the available nodes into the cluster, but not all nodes. Like, so based on your replication factor, file size, it will be divided into blocks and then it will be loaded. Okay, so let us go back to here and see what is here. So we have seen a file called 200 GB file. It has been some blocks. So how it will be divided? What is the size of the block size? So we have some block size available here. So based on the Hadoop version, Hadoop 1x, okay, 64 MB block size. Hadoop 2x, 128 MB block size. Block size. Okay, let me write it, block size. And if you are going Hadoop 3x, if you are using Hadoop 3x, it will be block size will be 256 MB block size. It will be divided based on your, for example, if you copy a 100 GB file or else 500 MB file, just imagine, just calculate it. Let me take a calculator. So for example, if you are using 600 MB, just imagine 600 MB file size, this is file. Okay, so if you are using Hadoop 1x, so by default it will be 64 MB for one block. So it means by 64, so it means total 10 blocks it will come, right? 10 blocks. So let us count it. 64 into 9, how much? 576 blocks. So remaining 10th block is less than the block size, right? That is what it will be decided. So here you can see, for example, this is a 600 MB file. So the blocks will be like block 1, block 2, block 3, block 4, block 5, block 6, block 7, block 8, block 9, block 10. Like this, it will divide 10 blocks for the 600 MB file and it will store into the data nodes. And also each block has been equal parts starting onwards. 64 MB, 64 MB, 64 MB, all 9, but last block is not the 64 MB. It is less than the 64 MB or equal to the 64 MB, because we have seen here how it will be. For example, if you copy a 600 MB file by 64 MB, it means 9 blocks, and remaining 37 MB will be a 10th block. 10th block, like this way. So it means when you copy a file, it will be divided based on your Hadoop version, and it will be equally divided almost all blocks, not last block, except last block. Remaining all blocks are equal size. The last block is equal to a block size or less than the block size. Right? That is what Hadoop will be storing. It will be dividing. When you copy a file, it will be dividing and storing into the respective data nodes. Okay, so and also at the load of time, data is distributed across all nodes. It provides the efficient processing. So and also it is loading the data into all the data nodes. When you are reading or writing, it is fast accessing. That is what Hadoop is useful. Hadoop is designed, and it is more powerful when you are trying to read the file or write a file. Okay. So what are the key points of Hadoop? So we have just discussed. Default block size is 64 MB if you are using Hadoop 1x environment, and if you are using Hadoop 2x, 128 MB block size, and if you are using Hadoop 3x onwards, it will be 256 MB. What is 1x, 2x, 3x? Okay, so let me take it. So Hadoop is started with Hadoop 1.0 and then 1.1 and 1.2 and also 1.0.1.1.0, 1.2.0 and also 1.2.1, and like the versions 1.3, 1.4 and also like by end 1.9, 9.2 something versions, and then later 1.10. Instead of 10, they'll call it as 1x. Total versions from 1.0 to 1.10. So they'll call it as Hadoop 1x. Hadoop 1x environment. Total. Remaining all, it's clubbed with from 1.0 to 1.10. All versions they'll call it as 1x complete. The same way Hadoop 2x. It will started with Hadoop 2.0, sorry 2.0 and 2.1, 2.2, 2.3, 2.4, 2.5, 2.6.0, and here we have some more versions 2.6.5, something like. Again by end 2.10. Instead of this, they'll call it as 2x. The same way started with 3x also. That is called Hadoop 2x, 3x, 1x. Okay, so that is, we'll call it as Hadoop versions. Okay, so based on the version, the block size has been defined by Apache Hadoop. Apache. Okay, and also you can see the theory part. Every file is split into blocks. That is mandatory in Hadoop distribution. When you copy a file, every file will be split into pieces. That pieces will call it as blocks, and every block is replicated on 3 times by default only. So if you want, you can change it, the replication factor. Block is never replicated on the same data node. You can see in the right side, for example, block 1 will be different data nodes, not on the same data node. Second copy, this is first copy, second copy, third copy, right? And block 2, first copy, second copy, third copy. Same way some block 4, first copy, second copy, third copy. So all these blocks, files, metadata will be storing on name node. This is called metadata, where the location of the blocks, block name, replication types, file owner of the file, file permission, everything we'll call it as metadata. Okay, so let me go back. Okay, so let me show it. The next one, the next features. What are the features of HDFS? High performance. What is it means? So when you are using Hadoop in a clustered environment, it means clustered means, what is mean by cluster? More than one computer connected with the network is called a cluster. Computer, more than one computer connected through a internet in a network called cluster, right? So if you are using more than one computer, so when you try to copy some data, or else when you read, if you want trying to read some data, it will be fast. That is called high performance. It will be very fast. So when you try to copy some data from outside to Hadoop, or else when you want to read some data from Hadoop to writing is fast because of available resources in the respective machines, respective hardware, memory, everything it will be using. That is what high performance. Okay, so faulty tolerance. What is meant by faulty tolerance? Faulty tolerance is, so simply I can say, if you copy a file, okay, so we have, it has been divided into blocks, and each block has been replicated 3 copies, right? For example, if one of the reason, so let us go back here. So this is 3 copies, right? So block 1 first copy, block 1 second copy, block 1 third copy. So for example, if some reasons, any of the reason, this node, this machine goes down, this machine is having some problem. Okay, so 1 copy we will lose, but we have still 2 more copies are available. So we will not lose the data. If it is not divided by blocks and if it is not copied, what is the reason? So before copying the data into Hadoop, so just imagine if someone got deleted this file, if you don't have a backup, what will happen? You will lose your data. That is the scenario. Here Hadoop has been avoided that scenario. If you copy a file, okay, if you copy a file and this has been divided into blocks, each block has been replicated three copies. No problem. If one copy goes down, we have 2 more copies available. We can use it. Or else another scenario, if second copy also goes down, you have 1 more copy of data available. Same data, 1 more copy. So using that you can gain it. So you will never lose the data. By the time what will happen if one node goes down? For example, in this scenario, this Hadoop cluster, one node goes down, some reason, any of the reason, either hardware issue, software issue, network issue, this machine is a physical machine, some laptop or server. If it is down means what is it means? That machine is not working. In the sense it is down. If it is down means, okay, so what they will do? So name node will try to monitor, keep on monitoring the node machine status. Okay, so if the machine is not up, it will wait for some time. So still the machine is down. So name node will try to replicate one more new copy into that available data, into that missing, I mean the corrupted node. For example, if this node is having 4 blocks, block 1 first copy, block 3 first copy, block 5 first copy. So this is not available anymore into Hadoop. This missing copy will be replicated into any other available data node automatically. But the time is 10 minutes 30 seconds. So name node will wait 10 minutes 30 seconds. If the data node is not up, so for example this is down, if it is not up the next 10 minutes 30 seconds, so name node will replicate these missing copies, available missing copies from here to any other available nodes. That is what it will work. So name node will take care of everything. That is architecture design. Yeah, fine. Okay, let us move it. The other one, that is what faulty tolerance. We will never lose the data. Okay, and relatively Simple centralized management. What is it means? Simple architecture. Hadoop will follow simple architecture, master and slave architecture. One master, multiple slaves. Yeah, simple architecture. Master, slave. And also security. Simple strong security mechanisms applied in Hadoop. There are default security is called ACLs, which we'll be talking about later. And so we have a Kerberos also. Kerberos is one of the security concept which we can enable it as a application type. We can include that. And it is optimized for distributed processing. Data locality. Try to run the task where the data nodes are, where the data is available. That is more optimized for distribution processing. Okay, that is what HDFS features. So one more, the next one is when you are after building your cluster. So as a Hadoop admin, so you need to build the cluster, Hadoop cluster. After building the cluster, after you build the cluster, the first activity, one-time activity is you will need to format the name node. That is one-time activity. Enter the cluster, that is a one-time activity. So if you format the cluster, then there may be two files will be created. That file names will call it as metadata. What is that file names? Metadata files, and file names are fsimage and edits. You can see it here. The metadata files will be created. The file names are called fsimage and edits will be created when we format the cluster for the first time. Okay, and format. So how to format? When you format the dfs.name.dir directory and erase if any old data is available on that node, that file, it will be erase it, and if any data is there, it will be removed. And a unique namespace ID. When you format the cluster name node, unique ID will be assigned. That ID will be unique for entire life cycle of the cluster. If, for example, if you formatted the name node and you assigned a namespace ID, after 1 year, after 2 years, so name node is having some problem, so you cannot recover back. So if you are going for format again, that unique namespace ID will gone once you formatted second time. So until that format of second time, the namespace ID will be single or unique one. Okay, and also when you format the cluster, when you format the name node, a pseudo file system will be created. So based on your Hadoop version, it's a 60, if it is 64 MB or 128 MB or 256 MB, block size will be on top of native file system. It will a pseudo file system will create. And to format the name node, the below command Hadoop space name node space hyphen format. It will format the name node. Okay, let us. So what is the use of this namespace ID? The namespace ID. So what is the namespace ID? When you formatted, a namespace ID will be created, right? So what is that use? Unique namespace ID is assigned to the file system. When it is formatted, it does not change the throughout of the life cycle of the cluster. So when you formatted, a namespace ID will be created. That ID will not change entire life cycle of the cluster. Okay, and also a handshake is done by each data node. So when you formatted the name node, a namespace ID will be created. Using that namespace ID only, from the name node, all the data nodes will communicate. That is the usage of the namespace ID, which connects to the name node during the startup. And the purpose of his handshake is to verify the namespace ID and the software version. So it means the namespace ID will be a communicator between name node and the data node. So to communicating with both, namespace ID required. If there is no namespace ID for any of the data node, that data node, we cannot use it into the cluster. Okay, data node service is automatically shut down if there is no mismatch or if the namespace ID is not matching with data node and name node. So namespace ID is stored on all the nodes in the cluster. and any node with a different namespace ID will not be allowed to join as a cluster by name node. For example, if we have 100 data nodes, okay, and one name node, 100 data nodes. So one data node is a different namespace ID. If you are trying to joining into that name data node into the cluster, so name node will not allow. Since namespace ID is different name node and data node's namespace ID is different, so it will not allow. Okay, and new data node is allowed to register with the name node and receive the cluster ID. Then only it will be allowed. So this is the data node registration process with name node. First, if you take it name node cluster ID, it means namespace ID 11141s, right? And if you take a new data node, there is no cluster ID. So when it will communicate to the name node and then get the cluster ID, it will be registered. If there is no cluster ID, it will connect. When after connecting to the name node and then registration of the cluster ID into the new data node, so it will be registered. And if you're trying to, you have one more data node, when the cluster ID is different. So okay, so when you try to using this join with this name node, so different cluster ID, it will not join. This will shut down. This data node will not allow to join to the cluster. Yeah, these are the steps. Step 1, 2, 3 registration process, 4 get the cluster ID, 5 it will try to check both match or not. If it is not matching, shut down the data node. Yeah, and communication between name node and data node. Data node sends heartbeats by default 3 seconds. So how to communicate name node and data nodes? Generally, how they will communicate? Using a simple heartbeat mechanism. Okay, so it means all the data nodes will send a heartbeat signal to the name node by default every 3 seconds. It means data node is sending I am available, I am still alive, and I am available. The signal will send it to name node. So name node will not send any signal to data nodes. Only all the data nodes will send signals to the name node. Each and every data node, they'll send a signal to the name node. Okay, and name node notifies the blocks that have been received. And also in place of, again, instead of like in terms of heartbeat signal, they'll send it like more information, blocks, how many blocks the data node is having. Okay, and what is the free space of the data node? So nodes, after copying some data, it will be still more space, right? So what is the free space? How much free space? So everything will be reported to name node from data node. Okay, so that will be notifying. And in response to the data node heartbeat, name node send the commands. So apart from that, if name node still required more information from the data node, they will ask it. Name node will ask from the data nodes. Okay, so that is what it is here. And all communication between name node and data node happens by RPC calls through TCP/IP port. So all the data node and name node will communicate with TCP/IP, Transition Control Protocol, Internet Protocol. Using that, they will communicate it. Okay, and name node never initiate the communication. One more thing, name node will never ask any information individually to the data nodes. So data node only will need to send it all the information to the name node. Okay, and it will send the commands like block replication, block invalidation, block report from the data node, etc., etc. And in the same channel of the heartbeat signal. In the heartbeat signal itself, they will try to ask, unless and until name node will not ask any more information. Okay, right. And other one is communication between data nodes. How the data nodes, every data node. For example, if cluster you have 100 data nodes, how it will communicate each and every data node one by one. So data node instances can talk to each other by using HTTP protocol. And this is mostly during the data replication phase or map reduce phase. Okay, so completely theory part, try to understand. So communication between client and name node. So all communication between client and name node happens by using RPC calls through TCP/IP port. So communication between client and data node. All communication between client and data node happens by streaming protocol. And also the other one, communication from client application to HDFS. The communication from the client to HDFS happens using Hadoop HDFS API. It is a REST protocol using HTTP protocols. Client applications talk to the name node whenever they want to locate some files. So one more point, the all Hadoop HDFS operations, first point of contact is name node. Okay, so we cannot directly communicate to the data nodes. End user, Hadoop admin, Hadoop developer, we cannot directly communicate into cluster directly. So first, through edge node, there is one more edge node. So we have some topic is there. Through edge node, we have to connect to the cluster, and then we have to locate the file. Where is the file available? So based on what the file is required, that file through communication only through name node will happen. Okay, so let us check. And how metadata is maintained in Hadoop. Metadata. So what is metadata? We have seen here. What is metadata? Metadata is a name node, right? Name nodes, it will store it to metadata. Metadata is like file information, file name, file owner, file properties, blocks information, blocks replication, permissions, everything. That is called metadata. Okay, that is metadata. So inside the metadata, how it will be maintaining? There are two files. Inside the metadata, there will be maintaining two files. One is fs image, other one is edits. The fs image, the entire file system namespace, including the mapping of the blocks to files and file system properties, is stored in a file called fs image. Name node keeps an image of the entire file system namespace in memory. Fs image persists to disk. So fs image is a file, it is stored on the disk. And edits. What is the edits? Rather than modifying the existing fs image every time, so the name node instead records of the new transactions in the edit logs for client applications. If the name node crashes, it can restore its state by first loading the fs image, then replying all the transactions, also called as edits, in the edits log to catch up the most recent state of the file system. So, and fs image and edits are physical files stored into the local file system. And also, what is edits? So fs image is a file. When you build the cluster, when you loaded some data, all the data metadata will be storing on a file called fs image, right? Then later, once your cluster is up and running some operations, so it means developers they're trying to write loading files and trying to analysis. So that each and every operation, they'll call it as a file called edits. They'll roll. It means a log will be generated in the edit log file. Each and every client operations is a record. That records, we'll call it as edits. Okay, let us see. So types of metadata. What are the types of metadata? The list of files, list of blocks for each file, file attributes like a owner of the file, permission of the file, timestamp, size, replication, array of blocks, and also list of data nodes for each block report. That is called metadata, types of the metadata. You can see it here, metadata, name node metadata. These are, what is this? File names, file name, and blocks number, block 1, block 2, and where are the blocks available in the data nodes, A, B, C, something, right? So these are the metadata, and these are the edits. Edits is like new records, new transactions happened into the cluster. Each and every transaction, for example, employee A transferred some file from outside to Hadoop, that is record 1. Employee B transferred one more file, second record. employee C did some operation, the record 3, like that. These are edits. Okay, so this is what where we can see it, types of metadata. And what is block report? Every time data node restart happened, whenever a restart happened, okay, it means it will send the informations to the name node. This many blocks I have, that is called block advertising. That is called block report. Block report bitmap is a logical file which will create it on name node memory, and the mapping between blocks and data node is never persisted to the disk when block report and bitmap will be updated. So in Hadoop Onyx, whenever you started a name node and restarted the name node data node, block report will be displaying. It means it will intimate the block report from the data node to the name node. And also dfs dot block report dot interval milliseconds, by default 1 hour in Hadoop Onyx and 6 hours in Hadoop 2x. It will report the block information to the from data node to name node. And on demand request from the name node. Another scenario, if name node required the block information from the data node, so they can send an email. Email means signal. They can send a signal, I want the block information from your data node. Then data node will send the report to the name node, right? And checkpointing, what is meant by checkpointing? Let me check. Okay, so checkpointing. So checkpointing is a process that takes FS image and edits and combines them into a new FS image. So what is this FS image? Metadata file, and also edits also metadata files, right? So this is first time when you're loading the cluster, right? And edits are new operations. So if it is continuously growing new operations instead of mixing, so for example, if name node goes down, this FS image we have a backup available in secondary name node, but edit logs we don't have any backup, right? So to avoid the situation after some time, so we need to merge these two, FS image and edits, and that is operation is called as checkpointing, and we'll merge these two and create a new FS image. And once the checkpointing is done, it means FS image plus edits are merged. Checkpointing is processing and done. Edit logs will be 0. Right? So what is it means? So it means, let me open a new paint. So this is FS image, edits, right? So FS image you have some 20,000 records. Just imagine, right? These edits we have 550 records. Edits all operations, edits 550 records. This is 20,000. Okay, so checkpointing. This is checkpointing. So it will clubbing. Checkpointing means all the edits and all the metadata will club it. So this is called checkpointing. Checkpointing, right? After the checkpointing, again this box will go to 0. It will start with 0, right? And total records will be created. One more new FS image here. So what is the size of the FS image? 20,000. What is the size? 20,000 plus 550. So 20,550 records will be storing. 20,550 records. So it means what we did, taking this file and taking these records and mix it. Mix it means just combined and created a new file. That file it is called new FS image. This one is FS image, left side, new FS image, right? And this file is called FS image, right? So after creating the FS image, what it will happen? So this FS image has been replaced to this. This has been replaced to here. So now this file, this metadata file, FS image 20,550 latest records, latest metadata. Then this will go to start with 0. Then again after some operations in the cluster, then it will be continue. So this is process is called checkpointing, and the whole process is responsible for, in Hadoop 1x, secondary name node is the responsible person. Secondary name node will do this checkpointing operation on regular time intervals on Hadoop 1x on every 1 hour in Hadoop 1x environment, Hadoop 1x version. So every 1 hour the checkpointing will happen automatically by secondary name node. You no need to do it. Automatically it will do it, checkpointing. But there are some scenarios available. That scenarios we can see. What are the scenarios? Okay, let us. So the checkpointing operation will be performed by secondary name node. And what is secondary name node? It is not a hard standby. It means, for example, if primary name node goes down, secondary name node will not work as a primary active. So it's only for storing of copy of metadata. Secondary name node usage in Hadoop 1x is to storing the metadata one more copy extra. One copy is available in name node, another copy in secondary name node. That is the only use of secondary name node in Hadoop 1x environment. Okay, and also Hadoop 1x, if the primary name node goes down, so we don't have any other master nodes, right? If active name node goes down, if name node goes down in Hadoop 1x, we don't have any other choice. The cluster will be down. That is single point of failure in Hadoop 1x, right? If Hadoop name node goes down, what will happen? Cluster goes down. Since all the files names are available in metadata, if name node goes down, we lose the metadata, right? That is the scenario in Hadoop 1x failure scenario. Okay, so let us next step. Okay, secondary name node. So how checkpointing happens? So we have seen, right? So active name node connects to the name node and pulls the both edits and FS image, and it will merge it. Rolls a new edits.new file, and it merge edits and FS image. It pushes it back to the active master, and this is done over through HTTP channel REST API. And also when checkpointing will occur. So every 1 hour. In Hadoop 1x, every 1 hour one checkpointing will occur. So that is what third one, by default 60. And the first one is, for example, when you started a name node, when you started or restarted for some reason, so automatically checkpointing will happen. Right? And also manual checkpointing, as a Hadoop administrator, we can do it. Hadoop, the command, Hadoop space DFS admin hyphen save namespace is a command where we can do the manual checkpointing. And also the block size, dfs dot name node dot checkpoint dot transactions. So by transactions means each and every end user operations. So if end user operations are reached 10 lakhs transactions, automatically checkpointing will happen. And block size of the checkpoint, fs dot checkpointing size, if it is reached to block size 64 MB in Hadoop 1x, automatically checkpointing will happen. Out of these 5 scenarios, if any one can met, so automatically checkpointing will occur in Hadoop 1x. Okay, so this is 29. And note, secondary name node will not have the latest copy of the FS image if checkpointing is performed by the name node. And also, who is the responsible for checkpointing? HDFS without high availability of name node. secondary name node. It means Hadoop 1x secondary name node is a responsible point of checkpointing operations, and Hadoop 2x standby name node. Okay, so let us see.